Hello students, in this video let us discuss a short topic related to types of solids. You know what are solids? The solids are the substances which have definite volume and definite shape, right? But if you talk about the properties of the solids, they not only depend upon the nature of the constituents, but they also depend on their arrangements. That is, the forces which are responsible to bind all the particles within that solid lattice in a compact form, right? So, depending upon the nature of the bonds present within the constituent particles, solids can be classified into various types. The first basis of classification can be categorized as crystalline and amorphous solids. Crystalline solids are the ones in which long ordered arrangement of the particles are present. As a result, we can say crystalline solids have regular arrangements resulting in a definite shape, right? So they have well defined edges, well defined phases, and as a result, they have sharp melting points. However, on the contrast, as far as amorphous solids are concerned, here the particles are arranged randomly. That is, they do not have ordered arrangement. That means they have irregular or curved surfaces, right? As far as the melting points are concerned, since they have irregular geometries all over the crystal lattice, so they melt over a wide range of temperature. Since we are talking in this particular video about the solid state involved, okay, so we need to concentrate ourselves on the type of crystalline solids which can exist. So the crystalline solids may be classified into 4 different classes. First one is the molecular solids. Molecular solids are the one in which the constituent particles are molecules. These molecules are held together by weak van der Waals forces. Take an example of, say, solid carbon dioxide, ice, iodine, and so on. They all have weak forces between their particles. Ionic solids. This consists of positively and negatively charged ions arranged within a regular fashion throughout the crystal. These ions are held together by strong electrostatic forces. For example, you can consider any salt like NaCl, NaNO3 or sodium sulfate, lithium fluoride, whatsoever, right? These are all ionic solids because they all have a common link between them. In this cases, positive and negative ions are held together by stronger electrostatic force of attractions. The third category is covalent solids. Covalent solids are the ones in which the constituent particles are atoms which are held together by covalent bonds. You can take as an example diamond or silicon carbide. Fourth one is metallic solids. Metallic solids in which the constituent particles are positive kernels immersed within a sea of mobile electrons. Okay, this you must have already been aware about when you study about the free electron theory, right? The C electron model as said. So the bonding of attraction, the forces which are present between the constituents within this type of metallic solids are called as metallic bonds. So any metal, for an example, like copper or nickel or any such metal, they all have metallic solids. To understand it, we can take certain examples. Like if you consider the first figure on the extreme left, that represents ice. And what we have already said, ice or solid carbon dioxide belong to the class of molecular solids. And so you can just, they have their brittle nature and you can just simply break the ice, right? So it's very brittle in nature. If you consider the exact crystal structure of this as shown in the figure, so we can say these molecules are held together by weak forces and those are called as van der Waals forces. Then on the right hand side, you can say a structure of sodium chloride has been shown to you. So you can see there a regular arrangement of sodium and chloride ions are been present all throughout the crystal lattice. ठीक है? And this represents ionic solids. Then the third one on the extreme left lower side, it is diamond. Diamond belongs to the covalent type of solids. So you can see there diamond is an allotrope of carbon. So all carbon atoms are present in this case. However, they are attached, or they have the stronger force of attraction between all the carbon atoms. The strong bonds are present, and this stronger attractions results in the formation of covalent bonding. So these are the covalent solids. The last one, which you can see on the extreme right, that is metallic solids. So you can see just the arrangement there. So that positively charged kernels you can see there, which is immersed within a sea of the mobile electrons, the negatively charged electrons. Okay, and this results in the formation of metallic bonds. So a stronger bond, a metallic bond gets formed between the kernels and the electrons which are present all over it. Right? This is the example of metallic solids. So that's for this particular video. Thanks for watching.